The next part we're going to go over today is adding and subtracting in scientific notation. So it's going to be fairly easy, but there's some things you need to watch out for. So, for example, when you are adding and subtracting, you can start adding and subtracting if your tens has the same exponents. So, if they are the same, then you can continue or start off adding with the two numbers that are in front of the tens, so my 2.1 and 7.3. So for this example, what I'm going to do is I'm going to write 2.1 plus 7.3 times 10 to the fifth. So again, you can start adding and subtracting the moment you see that the tens have the same exponent. When they do, then I'm just going to add 2.1 plus 7.3. That will become 9.4. So it's actually between 1 and 10, so I'm good with that. And if I look closely, the 9.4 has one decimal place, just like the 0.1 here, and then 7.3, they all have one decimal place. So I'm good with my decimal places for my final answer. And then I bring down the 10 to the fifth, and that will be my final answer. So as simple as that. The one thing you gotta watch out for or make sure of when you're adding and subtracting, you can start adding or subtracting when they have the same exponent on the tens. If not, then there's going to be an extra step which I will show you later on. But you can start adding and subtracting when the tens have the same exponent. In example 2, we have 4.3 times 10 to the negative third plus 9.1 times 10 to the negative third. So they both have the same exponent of 10, so I can combine these, meaning I'm going to add them together. So 4.3 plus 9.1 times 10 to the negative third. So when I do that, 4.3 plus 9.1, it will be 13.4 times 10 to the negative third. Now the issue is 13.4 is not between 1 and 10. So I'm going to have to move my decimal to the left one time. So it will be 1.34 times 10. Since I move 1 to the left, I'm going to put 10 to the positive 1 power. And then I bring down times 10 to the negative third power. So when I combine my two tens, they're the same base, and it's multiplying, so the law of exponents is that I'm going to add the exponents together. So it will be 1.34 times 10 to the negative second power. 1 plus negative 3, or 1 minus 3, is negative 2. Now, I gotta watch out because in the problem, it's one decimal place, that's the least. I have two decimal places, so I'm gonna have to round my number 1.34 into one decimal place. Since it's 0.34, this 4 is less than 5. That means I'm gonna round down. So it's gonna be 1.3 times 10 to the negative second. So that would be my final answer. So in this example, I got 13.4, so I have to move my decimal to the left one time, meaning I have to write out 10 to the 1 power, combine my tens, meaning the exponent, and then I got 10 negative 2. Then I also have to round my 1.34 into 1.3 because in my problem I had the least one decimal place, so my final answer has to have the least one decimal place. So my final answer is 1.3 times 10 to the negative second. in this example, we have 3.7 times 10 to the 4th plus 4.2 times 10 to the 3rd. Now the situation is the exponent is not the same on the tenths. So let me go over what we need to do in the event we have something like that. So say we have an example 2.1 times 10 to the 3rd power. Now if I were to move my decimal one place to the left, so it's going to be 0.21. If I do that, I'm actually going to add 1 to the exponent on a 10. So that would be 10 to the 4th. Now if I were to move my decimal 1, so let me show you up here, I move to the left. So that means if I were to move it one place to the right, so moving to the right, that basically means that since I moved to the right, I'm going to subtract from the exponent, so that's going to be 2. So if I were to start off in 2.1 times 10 to the 3rd, and I need to get to the 4th, I would move 1 decimal place to the left, since I want to go from 3 to 4. If I want to go from 3 to 2, I would move my decimal place 1 place to the right. Now the same thing is, if I start off with 0.21 times 10 to the 4th, and I want to get to 10 to the 2nd power, then I would just simply move my decimal place 2 times to the right, because I want to go from 4 to 2 by 2 units. So 0.21, and you see how 21, the decimal place is behind the 1, so the difference between 4 and 2 is 2 decimal places. So if you want to go from 3 to 4, move the decimal place 1 time to the left. If you want to go 3 to 2, move 1 decimal place to the right. And it's the same amount. So if I were to go from 3 to 5, I would move 2 to the left. If I want to go 3 to 7, I would move 4 to the right. So take note of this example. We're going to be applying this for this problem right here. So when there are different exponents on a tens, it's usually easy to stick with one way, which is mean I want to stick with the highest, so that's 4. So if I want to go from 10 to the 3rd to 10 to the 4th, so it's going to be like this. If I want to increase my exponent, I'm going to have to move my decimal place to the left. Since I want to go from 3 to 4, that's 1 unit, I'm actually going to move my decimal just 1 time to the left. So my new problem is 3.7 times 10 to the 4th plus 0.42 times 10 to the 4th. Now, you could convert into standard notation. It's just you're going to have a long number and you have to add them together and then convert back into scientific notation. Whereas here, this method is for you to continue working in scientific notation, and it helps you not work with big numbers. So had this been like 10 to the 7th, then you would have actually had a long number for the first one, and then another long number for the second one. And it's just going to waste a lot of space, and you have to keep track with all your zeros. Whereas scientific notation actually helps us add. So even though it's with decimal numbers, it's going to be pretty easy since it's only have 2 numbers here and 3 numbers here. Since they have the same exponent on a 10, it's going to be 3.7 plus 0.42 times 10 to the 4th. Now, to review, when we're adding decimals, you make sure you line them up. So I'm going to line up 3.7 and then 0.42. So I'm going to line them up the decimals when it comes to adding and subtracting. Now, even though it's 3.7 on top, I can just add a 0 to have the same amount of decimal place as 0.42. So when I add them up, it's going to be 2 here, 1. 7 plus 4 is 11, so 1 right here, carry the 1, so it's going to be 4.12. So 4.12 times 10 to the 4th. Now remember, you always have to check what was the least amount of decimal place. So from here, this is 1, this is 2, so the least is 1 decimal place. So I'm going to round 4.12 into 1 decimal place. Since it's a 2 next to the 1, I'm going to round down, so it's going to be 4.1 times 10 to the 4th. And this will be my final answer. In this example, we have 5.1 times 10 to the 6 plus 4.6 times 10 to the 7th. Alright, they have different exponents on the 10, so I want to change the 6 into 7. So I'm going to increase my exponent by 1 unit. If I increase it by 1 unit, I'm going to actually move my decimal to the left 1 time. So my new example is going to look like 0.51 times 10 to the 7th plus 4.6 times 10 to the 7th. Alright, so now I got the same exponent on the 10s, so I'm just going to add 0.51 plus 4.6. So 0.51 plus 4.6 times 10 to the 7th. And then again, I'm adding, so I'm going to line up my decimal. So 0.51 and then 4.6. Since it's 4.6 and the first number, it has 2 decimal places, whereas the second one, 4.6, has 1 decimal place, you can add a 0. Easy as that. So 1 and 0, that's just 1. 5 with 6, that's going to be 11, so I carry the 1. And then I was going to make it 5. So 5.11. 5.11 times 10 to the 7th. Now remember, based on my problem, I had 2 decimal places and I had 1 decimal place. So you always go with the least. So I'm actually going to round 5.11 into 1 decimal place. So it will be 5.1 because the second one right here is less than 5, so I'm just going to round down. And then bring down times 10 to the 7th. And this will be my final answer. 5.1 times 10 to the 7th.